Hi there. Let me take a few minutes and get you started on your online assignment, learning how to construct what's called an ogive, also known as a relative cumulative frequency plot. So hopefully by the end of this video you will understand what we mean by that crazy phrase. So first of all, the data we're going to use are from question 1.14. They are glucose levels on page 64. So you might want to start just by reading the paragraph, looking at the data at the beginning of that question, but you can stop. You don't have to read part A. So, because in part A, it suggests to construct a stem plot of the data, but that's not going to help us a whole lot when we construct a histogram. The histogram is what will be useful for making the ogive. So we're going to start by making a histogram. So to do that, you need to enter the fasting plasma glucose levels. Instead of saying that over and over again, I'm just going to say glucose levels. Enter them into list 1. I want you to run the one variable stats command then on list 1 and check to see that your sum is 2939. If you get that sum, then you've likely entered the data correctly. So I've done that. Let me show you how to do that. So on my graphing calculator here, press the stat button. Press the right arrow to go to the calc menu. One variable stats is the first option, so I'll press enter. So if you have a standard calculator, the one variable stats command would be on the home screen. You can just press enter to get the output. Here I'm just verifying that indeed I'm using list 1. I need to press the down arrow to select calculate, and there's the sum of 2939. So it looks like I've entered the data correctly, and we're ready to go on. So press second, y equals, and enter. We're going to set up our stat plot. So we're going to make sure that the first plot is on, and we're going to make sure that the X list is L1. That's where we put our data. I also want to make sure that a histogram is being plotted. So let's go back to the calculator here. Second, y equals. So I notice a couple things. Plot 1 is on, but it's not set to a histogram. It's sent to a line graph right now, which makes sense because I just used this calculator to do your other video. So I'm going to press enter. I'm going to go in here. The graph is on. I'm going to press the down arrow, though, and go over and select the histogram option. It is indeed list 1. That looks good. But I noticed something else when I was in there also. So we're only going to plot one plot. Notice that my second plot is still on from the last video I made where we plotted 2 time plots. So I'm going to go down to plot number 2. You want to make sure that that plot is off. To plot the histogram, we want to plot just one of them at a time. Fair enough. So in order to get that histogram, here is the window that I've suggested, and the window is particularly important because this scale is going to determine the width of the bars, and that affects very much the table in question number 7 that you're going to fill out. So it's important that you use exactly this window. Back to the calculator then, window button. The X minimum should be 50. The maximum should be 400. The scale should be 25. The y minimum of -2 and a maximum of 8, that is sufficient in order to see the bars and trace them for the histogram and see the results. A y max of 8 should be perfectly sufficient. So we'll hit the graph button. There is the histogram. So something to think about here then. In question number 6, I asked you to describe just briefly the shape of this histogram. So the graph is blank to the blank. So one thing to consider, it does look like this graph has a gap here, although I'll be honest, because of the scale that we've chosen, I can see 1, 2 little gaps there and a bigger gap here. So since there are multiple bars here of the histogram in this space, I don't consider this with gaps so much as I do as skewed to the right. So most of the data here is on the left, and then bars trail off to the right. So it would be perfectly okay to say that we have a gap here, but I think skewness is also appropriate. That's what I'm suggesting in question number 6. So it's always good to think about your shape, although in question number 7, we have a table to complete, and in order to complete that, we need to hit the trace button because I need to get the counts out of each bar of the histogram. Let's go to the table and make sure you understand exactly what I'm about to ask you to fill in. So we are going to complete the third column. This is the frequency column. So notice this was our X minimum. Our scale was 25. That explains how I got from 50 to 75. So the first bar of the histogram, notice there isn't a bar there, so it has a frequency of 0. We could see that on the screen. 50 to 75, there wasn't a bar of the histogram, so the frequency is 0. And simply by pressing the right arrow then, I can get additional frequencies. 75 to 100, we had a frequency of 3. 75 up to, but not including 100, there is our frequency of 3. From 100 to 125, we should have a frequency of 2. We can confirm that by hitting the right arrow. There is the 2, and so forth. So right arrow again, I have a frequency of 5. Here I would go from 125 to 150, a frequency of 5, and so forth, continuing to complete the third column, just by tracing and filling in your frequencies. Now, parts 8 and 9 then of your handout, those involve completing the 4th and 5th columns. So let me make sure that you understand what this means here. The 4th column, this is part 8, this is the cumulative frequency column. So by cumulative frequency, I mean adding up all of the frequencies up to and including the row that we are on. So on the first row, recognize we had no subjects so far, so the cumulative frequency is 0. By the time we get to the second row, we had 0 subjects from the first row. We have 3 subjects in the second row, so 0 plus 3, that indeed makes 3. For the third row, the cumulative frequency, I want to accumulate all of the frequencies up to and including that third row. So including subjects that are up to but not including 125 milligrams of glucose. So now that sum would be 0 plus 3 plus 2, that would make 5. So notice another way to get that cumulative frequency is to take the previous cumulative frequency and add the new frequency. 3 plus 2 would make the 5. So to get the cumulative frequency for the fourth row, I can start with the old cumulative frequency of 5. I have 5 new subjects in the fourth row, so now my new frequency would be 10. And so forth in order to complete the fourth cumulative frequency column. So now you can see why this is called a relative cumulative frequency plot. We are about to explain the relative part. We have done the frequencies, we have accumulated them. When we say relative, this is part 9, all we need to do is take all of the cumulative frequencies and divide by 18. All of these frequencies, we want to think about them relative to the total sample size of 18. So I'm going to take all of these, divide by 18, and simply fill into the nearest tenth. So, rather, nearest hundredth. So 5 divided by 18 is 0.27 repeating, so I can just make that 0.28. 10 divided by 18, that's 0.5 repeating, so I could call that 0.56, and so forth. I'm just taking each of those cumulative frequencies and I am relating them to, I am dividing them all by the sample size. So ultimately, what we will be doing then to plot our relative cumulative frequency graph, we will be plotting these percentages, the relative cumulative frequency column, those percentages we will be plotting against the second column. Fair enough. So read questions 10, or the 2 pieces rather, of question 10. Read them carefully. All I'm trying to do is to have you interpret. I want to make sure that you understand specifically what we mean by cumulative frequencies and relative cumulative frequencies. That's my goal. I will just mention a couple things here. So for instance, here's part 10. So for instance, we've already talked about this already, but I want you to think of it again in terms of the words. The cumulative frequency of 5 in the third row indicates that 5 subjects have a glucose level below 125. So there it was. 5 subjects total have a glucose level below that 125. So the cumulative frequency accounts for all of the subjects up to and including that row. So in question 10, I would like you to fill in the blanks and complete this just to practice a little bit. So similarly, fill in these blanks. The cumulative frequency that you can read here out of the 8th row. So we would be looking at the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th row. Here is where that cumulative frequency would be. That indicates that this many subjects have a glucose level below the upper boundary for that 8th row. So in the 8th row, the upper boundary is 250 for that bar of the histogram. So the second part then of part 10, question 10, I just want you to think about what relative cumulative frequencies mean. So for instance, the 0.17 in row 2, that tells me that 17% of subjects have a glucose level below 100. So here is that 17%. 17% of subjects have been accounted for by the time we approach glucose levels of 100. So similarly then, filling in the blanks, I want you to think about the 7th row. So the relative cumulative frequency from the 7th row indicates that a particular percent, so we want to get that out of the 7th row, 1, 2, 3, 4, 5, 6, 7th row, here is that percentage. A particular percent of subjects, again, have a glucose level below the amount which would be represented by our upper boundary in that 7th row. So in that 7th row, here is that specific upper boundary up to and including 225 milligrams of glucose. So up to question number 10, our goal really is to build the histogram so that we can complete this table and get our relative cumulative frequencies. Those we will use to make the ogive in the next video.